Hi disciples, welcome to Stats Cosmos. Today we are going to learn a very interesting topic. I hope you all will enjoy this. Let's go ahead and get started. This is the first video about the topic analysis of variance, more commonly known as Anova. In the context of Anova, it is important to remember that the F ratios are a central part of this, and it is simply a ratio of two variances. Anova allows us to move beyond comparing just two populations. With Anova, we can compare multiple populations and even subgroups of those populations. We can investigate how two groups interact with each other quantitatively. Many experimental research designs use Anova for these very reasons. This video offers a conceptual foundation about Anova using illustrations. The first and most obvious question is why Anova? If we have to compare two populations, we have t-test for independent samples and matched samples. But what if we wish to compare the means of more than two populations? And what if we wish to compare the populations each containing several levels or subgroups? And here is where we enter into Anova. So Anova, the acronym, comes from the phrase analysis of variance. Anova greatly expands what we are able to do in statistics. Let's look at an example. Suppose we want to find if the beverage that people drink affects their reaction time. So you set up an experiment with three groups of people. The first group gets water to drink, the second group gets some sugary fruit juice, and the third group gets coffee. Now, we want to test everyone's reaction time, and we want to know if there is any difference in reaction time between the groups. Here we can set up the null hypothesis, saying that the mean reaction time for all the three groups is the same. If there are only two groups, you could use a t-test to find out if there is a difference between them. But when you have three groups or more, you need to use a different approach, that is Anova. When you do experiment, the scores won't all be the same. The total variation of all the scores is made up of two parts. One is the variation within each group. People in each group have different reaction times, and variation between the groups. The drinks you gave each group are different. Here, let's look at an instance. The set of scores given here are sorted into order to make it easier to see the patterns. You can see that there is a lot of variation within each group. Some people are faster and some people are much slower. But each group looks pretty much the same. There is no much variation between the groups. In this case, you'd say that most of the difference is due to the people, and drink did not make much of a difference. And we would accept the null hypothesis, which is that the type of a drink doesn't have any effect on reaction time. Now let's look at another instance. A different set of numbers I considered here. In this case, all the scores within each group are very close to one another. There is no lot of variance within each group, but the groups are very different from one another. There is a lot of difference between the groups. In this case, we cannot accept the null hypothesis as the type of drink makes a big difference. So here is the idea behind Anova. We can identify how much of the total variance comes from variance between groups and variance within groups. Here F takes the ratio of between groups to within groups. And the larger the ratio, the more likely it is that the groups have different means and that you should reject the null hypothesis. In the instances we took before, it was obvious where the variance was. Now look at these numbers where we probably can't tell is there a significant effect because it's not clear whether there is more variance within groups or between groups. The calculations show that the ratio is 4.27, which has a probability of 0.04. So in this case, we reject null hypothesis. With these numbers, the drink you give the people does have an effect on their reaction time. Here 2, 12 are the degrees of freedom for variance between groups and variance within groups respectively. And here is how we calculate the degrees of freedom. First of all, degrees of freedom for variance between groups is equal to number of groups subtracted by 1. And the degrees of freedom for variance within groups is total number of observations subtracted by number of groups. And this is all about today's video. I hope you all understood the illustrations. Let's meet in the next video. Thank you so much all for watching this video.